Thank you so much, all of you, for joining today. Welcome to today's session of intermediate course in R with data visualization. So in the interest of time, let me just kick off today's session. But I would like to give you a brief overview, or just a high-level look at how our program has been. So today we are on session 6. That is 16th October, session 6. That is advanced visualization techniques using ggplot2. So today actually marks the end of data visualization in this training. Then my colleague on 30th October, my colleague will come and cover time series, which is a very important aspect when we're dealing with data and how that can be visualized. Then on 13th November, my other colleague Ludovic will come back, and he will also cover an introduction to Shiny and Plotly, which are critical when you want to create dashboards for visualizations. So today is session 6. So I'll cover the remaining part of advanced visualization using ggplot2. Then next week, we'll review today's session together, including looking at the exercises which I'll share tomorrow, as well as any other questions that you may have. So please feel free to come. Please feel free to come to our e-learning platform on this tab here, and you can register for the course here. We had a previous one, which was Introduction to R for Health Researchers. If you're new, you can just feel free to first of all check out the Introduction to R for Health Researchers. Do the quizzes there. There are lessons which are there. Then you can actually get a certificate of doing that course. Then you can also enroll. So actually, the prerequisite for this was supposed to be Introduction to R of Health Researchers. So then you can also register for this and also do it and follow up. And don't worry, if you did not do, if you're not been attending the other sessions, you still have a chance to look at it here. Okay. So that is just a brief overview of where we are, or the status of our training as of today. So let me share my screen, and we continue with the advanced visualization using R. Okay, and we've actually seen some really interesting visualizations in the past few sessions. So today, actually, I would just like to wind up what we have been covering over the last few sessions. So we started off with a review of the ggplot, what we had actually learned in the first training. Then we looked at basic visualization techniques in R using ggplot2. We also talked about the qplot, which is a framework in base R, but it's no longer used because the developers of R actually advocate for people to actually transit to ggplot2, which has more functionalities. Then we've also looked at advanced visualization part 1. So today's session is a continuation of number 3. That is, so for today, we'll build on what we did last time. So last time, we looked at Sankey diagrams, and I had said that there are two ways this can be done. This is what is called a Sankey, and it's what's called an alluvial diagram. Both of them can be done in R, and they just support these two plots are just supposed to show you the transition of proportion over a number of stages. Okay, it can be a cascade of categories. So you just want to see, for example, in a hospital setup, if a patient comes in, you would like to be able to know, if you have the data, how can you track the number of patients who are actually being admitted, those who have been put on treatment, those who are being taken care of in the outpatient, and all that. So it becomes like a useful visualization to be able to know how patients are actually cascading throughout that care system in a hospital. So we had looked at Sankey plots, and where we used the network D3, which is a web-based visualization in JavaScript. But now, let us now look at something that is called alluvial plots. Alluvial plots, as you're saying, is one of the best for category transitions over stages. Okay, and it's we're saying that alluvial diagrams are very similar to Sankey plots in that the only difference is that they have no spaces between nodes. Remember, when you're though we will look at this shortly, when you are looking at Sankey plots, you will see that between the nodes we had spaces. For alluvial, those spaces are not there. Okay, and you actually the chart actually starts at y equals 0 instead of being centered around the x-axis like in Sankey. So those are the two differences between alluvial and Sankey plots, and we'll see about them. Then as I said last time, we looked at network, sorry. We looked at network D3, the one which we used to plot our Sankey plots, and this was, it was an interactive plot as we saw. But today, there are other packages that can be used to also do this in R, okay? And the beauty about these two packages is that you can leverage on the protocols in ggplot2 to assist you to have better visualizations as well. So these two packages are ggAlluvial. You can see this bullet down here. And we also have ggsankey. So these two actually can be used within the framework of ggplot2 as an added geometry. I hope you remember how we are adding the geometries in ggplot. But now, once you actually install and load this package, like the ggAlluvial or ggsankey, you can be able to call an extra geometry that plots ggsankey. Then, so for network D0 Plotly, we saw that these were interactive, but the diagrams that you're going to get from alluvial and ggsankey, these ones are the ones, they're static. So you can actually, you can save them. They're static diagrams, they're not interactive, but they produce high quality images that can be used for things to do like publications. Okay, so if you're interested, though I will not look at ggAlluvial, you can just install packages ggAlluvial, and for ggsankey you can also do the same. Install packages ggsankey. Those are packages which are there. But unfortunately for ggsankey, you will have to use what is called DevTools. So because we will be installing it from GitHub. So you can do install packages. First of all, install DevTools. Then you can use this line here to install ggsankey. Okay. So, and you can see now from this package, you say that the goal of ggsankey is to make beautiful Sankey, alluvial, and Sankey, what they're calling Sankey bump plots in ggplot2. So in as much as we were using the network D3 for Sankey, now ggsankey can actually do for you all this. It can do for you Sankey, it can do for you alluvial, and it can do for you what we call a Sankey bump plots in ggplot2. But you may ask yourself, what is really the difference between all this? Okay, we will look at it shortly. But remember, all these are plots, are possibilities within the ggsankey, and this is in addition to using the framework of ggplot2. Then, now, here comes the difference I was talking about. So we will use the ggsankey package to get there, to get the geom sankey, okay? We'll also do the geom alluvial to get the alluvial diagram, and we'll also use the geom sankey bump to get the geom sankey bump. And all this are actually from that GitHub page. I've just borrowed this from that GitHub page because they give a very good difference of how these plots are supposed to be. So what we have here on your bottom left, that is an example of an alluvial. And you can see for alluvial, there are no gaps between nodes, okay? there are no gaps between nodes. So you can see, like for cylinder, VS, AM, gear in this figure on the bottom left, there are no spaces between the nodes, and it starts from 0. Unlike what you have on your top corner, top right here, that is what is called the ggsankey. Between the nodes, we actually have gaps, and the diagram is basically centered along the x-axis. So that is the main difference between alluvial and ggsankey. Then we also have what is called a ggsankey bump. This one is a beautiful plot, but it is more suited for time series data. Okay, as long as you have data that is time series based, then you can use a ggsankey bump, and it will give you a very good plot for that. Okay, so these are just parts of or elements that we're going to look at in the ggsankey. That is the ggsankey, alluvial, and ggsankey bump. Okay, and those are the main differences of these plots. Then how we actually build okay, just a minute. How we actually build the ggsankey in the framework of ggplot2 is that we will have our data, and there's a very important function in the ggsankey which is called make long. Make long just ensures that the data is transformed in a way that ggsankey for alluvial and ggsankey, that those visualization frameworks will actually understand. Okay, we're going to see that shortly. Then ideally, for a Sankey plot, the same principal structure as aesthetics remain. We have the nodes, we have the flow, and we have the stages. Okay, so basically the flow is determined by the value or the proportion of the shift from one node to the other. That's what determines the size of the flow. Then additionally, you can also have options in these plots whereby you can define the color, you can define the fill, you can define the shift, and all this. These are just additional aesthetics, but the principal aesthetics are covered when you're plotting that Sankey alluvial or Sankey bump visualization. So that is basically how these plots will be. We're going to look at them. Then now for the ggsankey, as I've said, there will be a very important function which is called the make long. Make long will take care of all these statistics you're seeing in this first row. That is x, next x, the node, next node. All these are required when you're doing a ggsankey, but that function will take that for us. Okay. You can also have you can determine that you can also do other things to actually control the geometry. In this case, you can have the node fill, you can have the node color, you can define all the colors that you want. You can also even have the transparency, that is the alpha, or the width of the nodes, okay, or the flow color on all this. This can actually be, these are options that you can actually find in the ggsankey or the ggsankey package, okay. Then after we are done with the Sankey diagrams, there's also another very important kind of visualization that is called the demographic pyramids. These are very important for people who are doing who are in population health, and for people who are actually collect routine data from health facilities, but you may want to know over a given period of time, what are the demographics, or how the demographics spread out or distributed between in a given population, so to speak. So, and you can actually disaggregate this again into gender. It can be into programs which you're running in those facilities. So demographic pyramids are very important kind of visualizations that we can also look at. Okay, an example is what we have here. This, and you can see on your y-axis you have the age categories. Then on your what you're calling the x-axis, you have now the percentage of the total. So you can have what is called a proportion of the total, the percentages. Then you can look at it. This one the visualization is categorized or classified into male and female. Very beautiful and very powerful visualization when it comes to demographics. So for this one again, we are going to install another package which is called a pyramid. A pyramid. It's a pyramid, but with a prefix A. So a pyramid, and a pyramid basically, if you look at its usage in the R environment, you can see that you need the data, you need the age group, and you need the split that you want. You look at, do you want to stack it by? These are just options that you can look at, and the count. But the ones which have to be there, number one is the data, age group, and the split. Okay, these ones are very important. The other options, options which are there exist. The proportion, if you want to actually visualize the data according to the percentages. You can also, whether you want to remove numbers which are not defined, NA, you can remove them if this option is changed to true. There's also the midpoint line. You can also choose whether you want to have it or not. But this just gives you for a given bar, because these are actually bar plots. You can decide whether you want to have a mid value to actually be visualized in that particular plot. You can have palettes. This is the last option. You can determine actually your own color schemes if you want. Okay, and all these are just some of the options that you can use to actually improve the aesthetics of that demographics pyramid. But this one happens to be a very important visualization when it comes to population health. Okay, so we will install the packages. A pyramid is also will be the one we will also look at. So these are, so you can see once you've installed that, we'll look at a pyramid, and this is how you call that syntax for you to be able to plot. And remember, our data was HIV data, but in this case, our age group, because we had categorized our age to be age.cat, we call it there. But I would like you to split it by HIV gender, because that's how we had actually named or we had mutated our data to be. And you can see the plots that it gives. Okay, it's beautiful. It shows how the numbers are varying between the different age groups. Okay, and for both genders, that is the male and female, and you can have the line you're seeing here, which is the dotted line. It shows that is that is what we're calling the midpoint. Okay, now let's see, and you can see now on your x-axis, these are just counts. The patients were between maybe 0 to 14 were just counted, and male and female were just classified into male and female, and those were the numbers which actually plotted here. But if you choose to have this option here, which is called a proportion equals to true, what you're saying, or what you're actually telling that function is, I want the plot to be as a proportion of the total. Okay, so the scale on the x-axis will actually change to be percentages. Okay, this can also be another useful way that this can be also be visualized. Okay, so we'll look at some of these examples shortly, but these are just other ways that we can continue visualizing that data. Okay, so then in our shortly in our practice session, we'll look at some of these different pyramids and how we can explore how the aesthetics of these visualizations can be implemented. Then before we actually, there's also another class of visualizations that are very powerful and are aesthetically pleasing. And these are what we call Tidyplots. Okay. Tidyplots is not part of the ggplot2, is not part of any other visualizations that you have seen. It just stands on its own. And you have to install this library, which is called Tidyplots. Okay. And it gives you basically plots like this. You can see the plots have their own aesthetically pleasing color schemes. And this can be another option of visualization, data visualization in R. Okay. Please take note of that. And these are also other kind of plots that can be visualized from this. And please, you can visit this tidyplots.org for more information. But I thought it was just very important. It was important that we also mention Tidyplots. Tidyplots is also a very powerful tool when it comes to data visualization. Okay, so please check it out. And they have so many kind of types of visualization which have been done there. And you can just improve. If you want Tidyplots, Tidyplots I think also offers a good option besides ggplots too. Okay, and they're equally powerful. Okay, I actually find the Tidyplots to be aesthetically pleasing than than ggplots too, but that's just a personal preference. So please check them out. And for now, let's go back to the practice session. We look at all that you have seen shortly. I don't know whether there's any question up to now. Okay, let me share my R script. Then so I've decided, because this one is a lot, we'll just go through what I've prepared. Then I will share the script. Then if you'll have any problems, we can just discuss them next week. Okay. And I hope this one will. Yes, let me share my screen. So any question up to now? Any question? Okay. So kindly, I know we have gone so far, but there is some adjustments I want us to make. I want us to increase the age classifications or the age groupings from the ones that we have now. Okay. Let us have 0 to 5, and remember we can just do this in the environment of using the cut function to actually group continuous data. And you can see this one. I would like us now to have 0 to 5, 6 to 10, 11 to 14, 15 to 24, 25 to 39, 40 to 49, 50 to 59, 60 to 69, and 70. I know we had used the previous one. Let me show you the ones that we had used previously, because it's the one I was just showing a few minutes ago. This one here. This is the one that we have been using previously. 0 to 14, 15 to 24, 15 to 25 to 49, 50 to 59, and 60 plus. I just want us to increase this age grouping so that we can have finer or we can reduce the width of the bars, and that one becomes even more pleasing to the eye. So let me. So I have done that, and let me also. So what we'll do, I'll just run my script the way it is the same one that we have been using, that has been shared. The only difference I wanted us to make today was to increase the number of age groupings, so that if I come and look at our age groupings here, we have now 0 to 5, 15 to 24, and 80C. Okay, so the age groupings we've increased them. Then remember, because we still want to review what we did for the Sankey plots, we'll also need to load tidyverse. We can use Pacman. We want to load Pacman and the network D3. Okay. Then this is just a review of what we did last week. Remember how we were creating the nodes for the Sankey diagram? Okay. This one is the one which you're saying that it is interactive. Then I would like to plot my Sankey diagram. And you can see this is what we ended up having, okay? But now I want us to go a step further. I want us to increase the number of nodes. And the number of nodes in this case, I want you to have this in this sense. I would like to have edge category, what you're calling the edge.cut. Then I would like this to go the next node. I wanted this to be the hospital of diagnosis. Okay. Then after this, I wanted us to go after this. Now I'm just trying to look at the cascade from edge category, hospital of diagnosis, and finally, what you're calling type of diagnosis. Okay. We also have type of diagnosis. Then, after one has been diagnosed, what the next element is case management, type of management. Okay. Sorry, management. This presents us with something that we can do with using a Sankey diagram, because now I would like to know of the patients who actually visited these hospitals, what was how was the age distribution? What was the hospital of diagnosis? Okay. What was the type of diagnosis? Okay. What was the type of management? Okay. And this can actually be visualized using a Sankey plot. Okay. So just have this in mind that when I'll be doing this, for the first node, age becomes the source. Then for when age.cut is the source, then hospital diagnosis becomes the target. Then in the second in the second class of nodes, hospital diagnosis becomes the source, but type of diagnosis becomes the target. Okay. And finally, in the last class, we will have type of diagnosis becoming the source and type of management becoming the target. Okay. We are going to do this, and because our data has about 1,500 variables, so that we can have a feel of the visualization, I just restricted us to about 10 hospitals. Okay. And we see how that will be visualized. So from my HIV data, what I'm doing is that I just want to access the first 10 rows, okay, but all the columns. Then from there, I will use the piping operator that we have already looked at. What do I want? I know there may be some undefined entries in that age category, so I want to drop them. Okay, so drop NA age cut. Okay, so this one drops. So you can see this one drops undefined elements or entries for that matter. Then for the first source and target, what do I want from that data set? What I need to do, I just need to work with hospital of diagnosis, and I need to work with age cut. Okay, that is the category of the ages. Then once I select that, what do I need to do? I just need to name them. I just need to count what was the number for each, what are the number of patients for each age category, and how many attended a given hospital for that diagnosis. So what do I need to do? I just need to do count. Okay, just the same way we did last time. Then just for the sake of brevity, what I'll do, I just rename age category to be the source and my target to be the hospital of diagnosis. So what I was actually calling as the first class, or what you're actually calling as the first stage. Okay. Then So that is done. And you can see that after I do this, I assign it the name hospital HIV/AIDS hospital link. Okay. Then I will do the same thing, but now for this part now, where hospital of diagnosis becomes the source, type of diagnosis becomes the target. I do the same thing. So I'll select hospital of diagnosis and type of diagnosis. Okay, I'll do the same thing. I'll do the count, and I can rename now for this particular stage. I will rename my source to be hospital of diagnosis and my target to be type of diagnosis. Then I'll also do the same thing for the third one, because now for the third one, now I will only need type of diagnosis, and I'll also need the type of management, which leads me to, I select just the type of diagnosis and also the type of case management. I also do the count, and I'll rename them according to source and target. Then this data, because now it is what I have selected for visualization, I can bind them into one, just the same way we did last time. I will take the name of the source and the target. This one will be taken as characters, the same way we did with the last example. Remember us with the way we matched the nodes and the source and the target from this data set. Then our Sankey plot now becomes HIV data 3. This one here, after we have done the row bind. So this one is actually bind the rows of these 3 minor data sets. Then how will the Sankey plot look like? Let's look at it. This one will be something like this. So this is just an expansion of what we did last time. The one we did last time just had one stage. Now we want to have 2 stages, and we see how does this visualization look like. So you can see now what has actually happened. If you can see on my top right, what has actually happened is that we'll have the first stage. The first stage becomes the hospital of diagnosis. Then this one here, confirmatory, follow-up, or initial, that one actually forms the second stage, which is given by the type of diagnosis. And finally, what we have here is what we call the type of management. Will it be a community-based care? Will it be an inpatient? Will it be outpatient? Okay. And because we're using network D3, this one is what we call is interactive. You can see that as I hover my cursor over this flow of the links, it is being highlighted in a more darker color to actually show you that on which flow you're actually looking at. So you can see, you can look at the initial. So it shows that actually most of the hospitals, just besides Nakuru Health Center and Trans Nzoia Health National Center, the rest actually had so many patients who are coming for the initial diagnosis. Okay. Then we can look at the Trans Nzoia had a huge number of follow-up who ended up being taken to the outpatient for the case management. Then and remember these widths of this are determined by the numbers of the flow. So I think it will just be important if we also look at how our data 3 actually looks like. Okay, just for argument's sake. So you can see in my console here, what I have now, my target, these are the number of hospitals, the name of the hospitals. You can have the source which is given us as the age categorization. Then N becomes the number of patients in these hospitals, okay? And the ID, source, and target is what we actually did after matching the source and the node, okay? That is how that data looks like. And that gives us a very good Sankey plot. Let's, just for argument's sake, this is not tidy, but I know it can be improved how we actually select the 15 rows or 10 rows. You can actually look at doing this earlier than just calling the data set which has already been filtered, but that's okay. This is just for illustration. Let's look at this second plot. I've now added about 15 hospitals. So you can see now, this age 60 to 69 was actually missing from the ones that we were looking at. But now it is visible. And you can see most of these hospitals, actually inpatient forms a very huge portion of those who go for initial diagnosis. Okay, so this is just part of an interactive Sankey plot. And remember, for this one, we have used the Sankey network, and the Sankey network is part of this. Is part of the network D3 package. Okay, now that is for the Sankey plots. Okay, I just wanted to show you how this can be done when you have more than one node. Okay, it is possible, and you can actually increase them as many as possible. I would like you, maybe just for practice during your free time, maybe you can try to add the node of occupation, and you see how it will look like. Maybe you can try to add the node of the stage of comorbidity. You see how it looks like. Or you can also try to add prevention management as part of the stages, and you see how that visualization will look like. Okay, so you can see that that Sankey plot is actually a very powerful way to also visualize that. Now here comes, now that you can see, you've seen that uses is more of a network base that uses JavaScript visualization, and it's interactive. Let us now use or rather plot Sankey plot within the ggplot2 package. Okay. For this one, I would just like us to look at two classes. That is the viral load and the CD4 count from our data set. These two are related to one another. Okay, and you can try at least to link up these two. Okay, so the same way we've done that, because this data is so long, and the number of hospitals are so many, we'll just have we can just select a number of hospitals from our data by selecting the rows 1 up to 30. Okay, and all just the same way we've actually done that. Then, because okay, just so that you can be able to follow, let us open this data set here. So this is the CD4 count we have here, and you can see CD4 count has a lot of missing data. And also for the viral load, the VL also has a lot of missing data. So it makes sense, in as much as we are selecting this data, we also drop those missing values there. That's the reason for line 169. Okay, but our aim is just to select viral load and the CD4 count. Let's look at how this data set looks like. So this data set, if you want to visualize it of what we have just selected, you can see it is just the VL and the CD4 count for those hospitals, or for those hospitals that is 1 up to 30, or for those patients visiting these hospitals. So you just have 1 up to 30. Then now, here comes the function I was talking about. This one, make long. What this does, let me comment this and say this ensures that the data is understood, so to speak, understood by ggsankey. Okay, it's a very important state procedure to do, but it will just be the data that we have selected. Okay, that's the one we want. So once you do that, and if you want to check how the DF looks like, DF now, remember what I was talking about, the X, the next node, the stage, all these values now are defined. Once you do make long defines for you the X, defines for you the node, defines for you the next X, and defines for you the next node. Okay, So make long line 173 is an important stage to actually pipe that data through. Then and that's it. So this one is a bit standard because it actually just calls the elements of the data frame which has been created after passing the elements viral load and CD4 count through make long. Then because now we are within the ggplot framework, if there's a geometry that we need to add now is what is called the ggsankey, and the ggsankey will just be added by plus. So this now becomes the geometry. This is this is a geometry we are adding now. The same way we are adding the other geometries like geom point, geom giga, and etc. Okay, let's see how this plot now looks like. And remember, we have said that this is a ggsankey, and a ggsankey has spaces between different nodes. Okay, so you can see this one is on the x-axis. Now we have the viral load and the CD4 count. So it just shows you we can just try to visualize, or just have to have an idea of how we can link up the viral load and the CD4 count. But that's how we load that geometry there. So I would like to just link this up because so that you can actually get the difference between a ggsankey and a alluvial, and we will use the same data the same data frame that we have created, only that this time I will come back to that. Only that this time we will do plus a alluvial, okay, plus a alluvial. So let's see. So let me just copy this first. All those you're seeing there, those are just options that can be added to the plot. Let me just do that first, so we just have a high level view of how the alluvial looks like. So you can see this is actually the difference between the two. One has gaps between nodes, but a alluvial does not have gaps. Then the alluvial also starts from 0, while the sankey does not start from zeros. Okay, let me undo this, and we go back to what we had here. So if I actually run this once again, so that you can what you have here now, the current plot being shown here, this is a alluvial. Let us do ggsankey and we see how it looks like. So you can see for ggsankey, there are spaces between the nodes, and it is centered about the x-axis, while the alluvial starts from y equals to 0. So that is the difference I was actually talking about. Now, just same as the other plots that we were looking at within the ggplot2 framework, it is also possible to actually have user-defined aesthetics within this framework. Okay, you can define the node color, the one which I showed you in the slides. You can define the node color. You can define the size of the labels. You can define the color. You can define the feel of these labels. You can even define color scales. Okay, something like Viridis here. You can define the size of the fonts that are given to label that Sankey plot and etc. You can also give you can also give the titles, you can give the labels and etc. Okay, let's see, because this one now will be an improvement of the Sankey plot that we saw, because now we have added options to it, aesthetics options. So you can see this one now is actually improved because now it has labels. Okay, it actually has the number of labels. That's one. Number two, we have user-defined scale fill, that is the color. Okay, in this case we're using Viridis. Then you can also have the labels now. The labels you can see, we are saying that the size will be 3, the color will be white, the color of the labels, but the fill will be gray, okay? So just gives you a beautiful visualization of what we actually want to look at, but now with user-defined options added to it, okay? Very beautiful. Then I think that the same case can be done to an alluvial diagram. We can also add aesthetics to it. Let's see, and it's for the same data, the same one that we saw, and for alluvial the same thing. You can see now the labels are there. They are appearing. The labels are in white. The size is 3, and the flow. You can see now line 224. Now you can actually define the transparency. You can define the transparency of this of the flow. Okay, that is the flow dot alpha. That is the links between the nodes. You can define how transparent those points will be. Let's say for argument's sake we change this to something like 9. How will it look like now? Okay, these are just options that can be added to this. So you can see now it has become much denser. The flows between different nodes and between different links between those nodes. Okay. GG title, this is something that we saw that is an option that is added within the ggplot framework. And the reason why ggsankey is a powerful way when you're doing ggalluvial or ggsankey is because you can leverage on the theme option in ggplot2 to improve the aesthetics of the plots that you're doing for the ggsankey, ggalluvial. Okay, very powerful plots. Okay. So I think I will send these scripts to you. I've tried to actually just demarcate these different kinds of plots. There are quite a number, but it'll just give you a good practice because this is the data set that we have been looking at over and over. And the elements that you're plotting, these are elements which are familiar to you. So you can just try to look at the other categories of data and look at how those can be implemented in what you're doing. But the most important thing when it comes to data visualization is trying to understand what you want, okay? So the first thing that is always is trying to understand how the data set looks like, okay? Once you understand the data set, how it looks like, the next element is what do I want to visualize and how do I want to visualize that? That will actually guide you as to which kind of visualization you can actually use, okay? So that is on geom Sankey and geom alluvial. The other one, which is also a good plot, I can say, or a good type of data visualization, but it makes sense when you actually use a data that a time series data to use the geom Sankey bump. Okay, we'll use the same data set that we do, but in this case, let us now select age category. We can group our data by age category and occupation. Okay, then we can actually count these ones here. So if we do so, and remember, these are things that we have already covered: the grouping of data, counting, and visualizing that. So let's look at how does DF1 look like. So we have grouped our data according to age category, occupation, and the numbers. Okay, so you can see 0 to 5, definitely they don't have any occupation. A good number of them who visited the hospital don't have any occupation, and there were about 60. Then 0 to 5, we are calling them students, though they can be nursery going children. Okay, they are about 42. Then 6 to 10, they don't have any occupation, definitely, but some of them can be students and etc. So we have grouped our data according to by age category and occupation. Then what we've done, we have also counted them according to that grouping. Okay, and you can also ungroup them because if we just look at the, okay, let me just do this for for argument's sake, the reason why we are doing the ungrouping is because you not want, so the data now looks like this. So we would like to, yeah, we would like to ungroup them because, sorry, let me just, we would like to ungroup because we would also like to remove a secondary header that always comes when you're doing the grouping. So this one has a different way or a different syntax that can be done. So notice that we are not using the make long function in this case, but we just have to define what do we want to be on our x-axis. I know in this case we have occupation, but it would have made more sense for this one to be. So let me just put that comment there. Makes more sense for this to be a time series variable. Okay, something to do with dates. Okay, but that's something that you can try. You can that gives you a very good practice to do. Though Ashna will cover it next time. That is the time series data. I don't want to preempt what Ashna will do, because now she'll show you how to split this data set, like the one you have here for date of sample collection and date of diagnosis. Next time, Ashna will show you how you can actually split this data so that we can have a column of years. And if you have a column of years, then it will make sense for X. That's line 245 for X to be years, for example. Okay. But I'll just do this for for illustration. Then you can actually have your nodes to be the age category. And what do you want to fill? You can have your field to be age category again. But then the value which will be displayed on the x-axis is this n. Do you remember this n here? This one here, which is the number of different occupations for different age groups. That one will be is the value that you want on the y-axis. Okay. So again, these are just aesthetics options that can be included. So we can yeah, these are just options that you can actually add. Each is the transparency. You would like the size of the text to be equal to 10. You don't want the labels on the x-axis, but you want the labels on the y-axis to be given as the name count. You want the legend to be at the bottom. You want the title of that plot to be age categorization. Okay, but basically the most important point is what do you want to be on the x-axis? What do you want to be as your node? What do you want to be your field? What do you want to be your value equals to n, which will be what will be displayed on the y-axis. Then, and the most important thing is the geometry. Okay, the geometry that gives us what you're calling the ggsankey bump, and the space. If you wish to have a space between those nodes, then it's actually possible. You can define it there. Okay. Then these are just options that are there to increase or to have a better or a visually appealing ggsankey bump. Okay. This one, as I said, it will make more sense if we have. So you can see it is a plot that looks like this, because our y-axis is what you're having as the count. Then our x-axis here is what we have as the occupation. Though, as I've said, it makes more sense if this is time series on the x-axis. So though we can actually see that a good number of people in the occupation had their entries missing, or rather the entries were missing. Okay, but you can see that this the way these colors, the colors of these Sankey bumps is actually categorized by the age category. So you can see 0 to 5, 6 to 10, 11 to 14, 15 to 24, 25 to 39, and etc. Okay. So I would like we shall revisit this diagram when we're actually done with the time series. Then we can use the x-axis as the time series. But this is just for illustration how the geom Sankey bump looks like. Okay, and it's also powerful presentation when now you want to connect the Sankey plot or rather the alluvial diagram now with time. What happens over time? What are the changes in the categories over time? What are the changes in these nodes or in these stages over time? Then a geom Sankey bump makes more sense to actually look at that. Okay. So that is all as far as Sankey and alluvial diagrams are concerned. Okay. These ones may not be as straightforward as the other geometries that we saw, the ones which are defined within the ggplot2, but they are also they communicate, or they're used to draw to derive insights from data sets in another way. Okay, as long as you have categories and you would like to look at how the cascades over different categories will look like, then these ones will actually make a perfect choice for that. Okay, that is the geom Sankey, geom alluvial, and geom Sankey bump. Okay. I had a bonus one here, though I'll just send it for you to look at it. Okay. It's when now you actually want to have, you have defined the nodes. I don't want to revisit this, but it's also a good one because you can be able to actually have just the way we have defined, just the way you have been able to actually have labels. It's also possible to have user-defined labels in the network D3, though it's a bit more complicated than the one we have for geom Sankey. For geom Sankey and geom alluvial is quite straightforward how you add the labels. Okay, but I have just added it just for practice, and if you wish to look at it. So let me stop there as far as Sankey diagrams and alluvial diagrams are concerned. Okay. I will share everything. You can look at them. We'll also give some exercises which you can try and note the materials. Then the other type of visualization we would like to look at is what is called the demographic pyramids. Remember, I said that we will need to install this package which is called a pyramid. Okay, a pyramid here. So I've already installed it on my end. Then how do you call it? You just need to define, because the options given in the age pyramid is, number one, you have to define the age group, because this is just a demographic visualization. You have to define the age group and what do you want to split by. Okay, you can split by occupation if you want. You can split by type of management and etc. But for now, let's just split it by HIV, gender, and we look at it. Okay. So let me first of all remove this proportion equals to true. Just look at it as a simple visualization here. So let me close this so that it doesn't cause confusion here. Okay. Hopefully I have not erased the environment. Okay. So in that case, if I just run this one now, it is what I had shown on the slides. In this case now, you'll have on the y-axis, you have the age categories. Then on the x-axis, you'll have the counts of different age categories for different genders. Okay. Now, assuming now that what I want to do the proportion equals to true. Sorry. Equals to true. So what will actually happen? Just observe what happens on the x-axis. What happens on the x-axis is that now they become percentages, the percentages of the total count, okay? The percentage of the, and the dotted lines that we see here, by default, they are always there. It just shows you the midpoint of those two bars, okay? Of those two bars. Then sometimes maybe let us remember for the first case we were looking at, we were splitting it by HIV gender, okay? Because this split by is an option in the age pyramid. Let us split it by things like type of diagnosis. Type of diagnosis, we have it here. If you look at our data set here, we have our type of diagnosis here: initial, confirmatory, follow-up, and etc. Okay. So if we split it by and remember now, by type of diagnosis, there are three. So we don't expect the same visualization as what we have currently, okay? Because now the groupings have increased by more than two. So you can see now it forms a plot whereby, is this familiar from what we have been seeing? You can type in the chat. Is this familiar? Is there anything we looked at that looks like this previously? Do you remember what we were looking at, the facet plots? It's also similar to looking at facet plots, but this one is just used to show age distribution. Now, for this case now, we have split our demographic according to the type of diagnosis. You can see that now for the first plot, this one is just for initial diagnosis, and the counts are there. The second, the middle plot, that is confirmatory, and the last one is what we call the follow-up. Okay, and again, the midpoints are there. What you're seeing here, the one in gray, you can see that for the first plot, you can see the blue part, the green part, then you have the gray part. The gray part is just the total in that age bracket. Okay, so you can see that it shows that for the initial cases, there are more than a half for 70 plus. Okay, then when you go to something like maybe 11 to 14 years old, you can see that also for initial, there was slightly more than half of the counts in that age bracket. So the proportion here is false. We can also just change it to true, and we see how this one looks like. So if we change it to true, you can see that now the values on the x-axis have been changed to proportions. That is the percentage of the total. Okay. So please take note that the ones you're seeing in gray, that actually is the total of that particular age bracket. But we have split them by type of diagnosis. That is the initial, confirmatory, or follow-up from our age, from our HIV data set. Okay. Now, there's also another option that can be added on top of split by. We can also decide to do what we call stack by, which can we let us, because this was type of diagnosis, let us also look at, we can stack them by type of management, because that's also what actually follows after diagnosis. Okay, management. Okay, let's see how this plot will look like. Oh, there's a comma which is missing here. Then this one looks like type of management. Type of case management. That is, I think nice, okay. Type of case management. So you can see now in as much as now we are looking at, we have split the age categories according to the type of diagnosis, that is the initial, confirmatory, and follow-up. You can also fragment this further and have them also include another aspect of that data. That is something like case management, okay? So initially what we had just a green bar, like for 70 plus, for the initial one. We just had a green bar. But now it is also possible to actually fragment that and have also those who are going for something like inpatient, how many are they? Those who are going for outpatient, how many are they? And those who are going for community-based care, how many are they? Okay, so that's also something that can also be visualized using the age pyramid. Okay, now just for argument's sake, let the split by here that we had, let us have it as HIV.gender. HIV.gender. How would this plot look like? Okay, how would this plot look like? So you can see now it is the one that we had previously, but now for the different age brackets, now we have actually tried to also disaggregate this into the type of case management. In how many are going for inpatients, how many were outpatient, how many community-based care, and etc. Okay, so it just depends on the split by the nature, whether this one progresses to become a facet plot, depends on how what you're splitting by. If it's more than 2, then you'll have subplots. Okay, but if it's just 2, like the gender, then you just have a single plot like this one. Okay. Then it is also possible again to define your own colors. Okay, like for this case, we have type of case management or type of diagnosis. If they are about 3 or 4, you can define the colors for this. Okay, let's look at this, and that can be under the option, the one that we saw, which is called PAL for palettes. And you can see now you can have your own colors now, because this one, for this case now, what you've done, we have defined split by diagnosis. This now is not gender. We are now split by diagnosis. And missing numbers, you've said, remove missing number, you've said is false. That's why you're seeing there is also there's also that plot on your lower right for missing, because, and you can see there are so many missing numbers for 70 plus and 25 to 39. But if you change this to true, if you want to remove any missing numbers, if you change that to true, let's see what that happens. You can see now that plot for missing has disappeared. But what you're left with is just the initial confirmatory follow-up with the type of case managed, but now with user-defined colors. That is the orange, purple, red, and green. Although it's not really a beautiful color scale, but yeah, you get the idea. Now, the beauty, again, I can say about doing this within the ggplot2 framework is that you also end up using additional aesthetics options that exist for ggplot2. So in this case, you can see that it was possible to use things like scale, labs, that is the ggplot2. You can also use the theme. You can also, and remember, within the theme environment, we can also define what we want to be the texts, how we want the text to be, and all that. All this from line, what I'm highlighting here now, all this is just from the ggplot2 environment, okay? You can just add these options so that you can beautify your age pyramid or the demographic pyramid that you have. Okay. So if we run this now, it's the same plots that we have just seen, only that now we are adding some more aesthetics to it, okay, including titles, subtitles, and etc. Okay. So if you do that, you just see that now you'll have user-defined colors, but now you also have at the bottom there you can see now you have the name of the x-axis, you have the name of the y-axis, you have the name of the title, you have the subtitle. The title can be type of diagnosis. Subtitle can be the segregation of the type of diagnosis stacked by gender and etc. Okay, so this just gives you options to be able to just improve the visualization of your demographic file. Then I think that is all that is there to age pyramid. But as I've been saying, it just depends on how you play around with these options. Okay, you can have options the way you want, user-defined options to improve the graphics of whatever you want to visualize. Okay, but that is born from understanding the data set, understanding what you want, and understanding the type of visualization that you actually want. Okay, so I don't know whether there's any question up to that point. Okay, so next is just something that is called the Tidyplots, and remember, you can just install Tidyplots. Tidyplots is known as a separate package that is used to visualize data. So it's called Tidyplots, and the thing is, what we can actually do, and as I've said, remember to visit tidyplots.org. You can see how the plots look like. Okay. So first of all, we can just sample our data here, because now I want to select type of case management from our data set. I also want to select age category, and also want to select type of diagnosis. If there's any missing entry in the age category, I want to drop it. Then I can just do the count. Then instead of having it as the number n, I just want to rename it to be the word number. Okay. So all this will just give us as a data set that looks like this. Okay. This is actually what we want. It's just the age category, type of case management, and you have the number there. Okay. How do you call this? Everything in Tidyplots is called within what you're calling the Tidyplots syntax there. Okay. And the thing is, with this one is similar. I can say it's almost similar to ggplot too, because now, but the main difference I would say, instead of using the plus to add layers to the plot, you're actually using the piping operator. Okay, because in this case, what you're doing, the data that you have created now, you want to pipe it into the Tidyplot. Okay, but what do you want to do? What you want to do is you want to X to be the type of case management, you want Y to be the number, and the color will be defined by the age category. Then you pipe that in, but now what do you want to plot? I want to add bar stack absolute. Okay, let's see what that one does to us. What it does, it just plots for you a small plot whereby the x-axis is the type of case management. Then the type of color in these bars has been determined by the age categorization. Then on the y-axis, what you have is the total number of this. Okay, but now This plot is too small. What do I need to do? I just need to pipe it again to adjust the size. So now I'm piping it and I'm adjusting the size of that plot so that it has width is 150 and the height equals to 100, okay? But now, as I look at this plot, I also see like the font is too small. What do I need to do? I can now pipe again, adjust font to that plot so that I can increase the font size. So the font size now has increased. So now we can look at community-based care, the numbers which are there, the inpatient and the outpatient, okay? Then I can also add the title, I can add the caption to this figure. All these options are actually piped. You actually have to pipe them in. So you can have now that the title of the plot is type of case management. The caption is age factor distribution of type of case management and etc. Now, what you've seen here, this line here actually gives you, just think of this as a geometry. This defines the kind of plot to obtain. Because now you can see it's add bar stack. So it's a bar plot, but has been stacked and it's absolute. Suppose there's also an option, if you check at tidyplots.org, we always have relative or absolute. I can change that to relative and we see how that looks like, okay? If you look at that now, it becomes as a proportion of the total, okay? So now it becomes a relative bar stack, okay? So all these are just from the tidyplots. I can also have one here which is called the same way. You just pipe the data into tidyplots. You define your axis and the color. Then after that, you pipe that in to determine the kind of plot that you want to obtain. For example, in this case, I want to, it's a bar, it's an add sum bar that you have. If you run that, you can see now it is bar, but we can also think of piping in the size the same way we did it. Let me just copy this so that we can just reduce what we are doing here. So that now so that it is possible to actually see what we are doing here. So if I do that, so you can see now it is a bar, okay? Not a stacked bar like the one that we saw. Then you can think of also piping in to add the title, to add the caption, and etc. Okay. Other options that exist include relative stack, area stack. Okay. Sorry, you can, okay. So I know this is familiar, so we can also just try to do, you can increase the size so that we see how it looks like, okay? It's just relative as a proportion to the total number of counts, but also you can also have absolute here. Absolute, yeah, absolute, that one. Then if you run this again, yeah, all these kind of plots are there. I know we may have different preferences, but from my end, I actually find that the colors in tidyplots are much richer, and the plots actually seems to be more aesthetically pleasing, but that is a view. But again, it depends with the user. Okay. So let me just take you to tidyplots just for a second. Okay, let me share my screen again. So I've just gone to the Tidyplots, and you can see for this case it's just the tidyplots.org. These are the kind of plots which are there, and there's a documentation, and actually there's a paper that the person who developed it wrote. It's called Yan. You can look at the paper. So it actually has very beautiful visualizations if you're interested in this. Okay, you can look at the cases which they have here. I just thought it would also be important that we mention there are other kind of visualization packages besides ggplot2. Okay, so this is actually also an option that you can consider. So, but you can, in any case, you can just try to mix the two, ggplot2 and tidyplots. Okay. So thank you all. I think we have come to the end of the data visualization techniques in R. So next week, we'll just do a review and we'll look at the quiz, which will be sent tomorrow. But please, if you have any questions, please feel free to ask us. And if there's anything you'll not understand from what we have covered today, feel free to join us next week. On Thursday, we will recap on what you've done. And hopefully, this actually helps you in what you're doing as a health worker, as a researcher, as a student. I find these plotting to be very powerful. Okay, it's just a way of drawing insights to what you want to do. Okay, so thank you all for joining. And if you have any question, please don't feel free to ask us on our platform. And with that, thank you so much. And I invite Virginia to close the session for us.
Yeah, Duncan, thank you. So thank you very much. And I noted maybe some dropped on the way, but it was a very nice session. And thank you for leading us through the advanced data visualization techniques. I don't know, for some of you who have joined, if it's your first time, please take time to go through the platform as Duncan elaborated in the beginning. Take the courses from the beginning. And also, as next week, Duncan will be rewinding through the practical session part of this. Just make sure you follow up through other previous sessions. And then finally, you can earn your certificate. Duncan, it has been a pleasure to go through the session with you again today. And yeah, today I think we didn't have our other facilitators, but yeah, but it was very nice one. Thank you very much, and see you all next week.